Video lecture chapter 2, lesson 2.2. X-ray machine component parts: control panel, extension arm, and tube head. The control panel contains an on-off switch, indicator light, control devices, time, kilovoltage, and milliamperage, and is plugged into an electrical outlet. The extension arm suspends the X-ray tube head, houses the electrical wires that extend from the control panel to the tube head, and allows for movement and positioning of the tube head. The tube head is a tightly sealed, heavy metal housing. It contains the X-ray tube that produces the dental X-rays. The metal housing surrounds the X-ray tube and transformers, protects the tube and grounds high voltage components, and insulating oil surrounds the X-ray tube and transformers and prevents from overheating. The tube head seal permits exit of X-rays from tube head, seals the oil, and filters the X-ray beam. The X-ray tube is the heart of the generating system, and the transformer alters voltage of incoming electricity. Aluminum discs filter out non-penetrating longer wavelength X-rays. Lead collimator restricts the size of the X-ray beam, and the position and indicating device aims and shapes the X-ray beam. The X-ray tube is a glass vacuum tube that measures several inches long by a 1-inch diameter. It includes lead glass housing, a cathode, and an anode. A leaded glass vacuum tube prevents X-rays from escaping in all directions. One area has a window that permits the X-ray beam to exit the tube and directs the beam toward the aluminum disc, lead collimator, and PID. Cathode is a negative electrode, consists of a tungsten wire filament and a cup-shaped holder made of molybdenum. Supplies the electrons necessary to generate X-rays. An anode is a positive electrode and consists of a wafer-thin tungsten plate embedded in solid copper rod and converts the electrons into X-ray photons. X-ray generating apparatus: electricity and electrical currents, circuits, and transformers. Electricity is the energy used to make X-rays. The current is the flow of the electrons through a conductor. Direct current, DC, when electrons flow in one direction through a conductor. Alternating current, AC, when electrons flow into opposite directions. Reciprocation, the conversion of alternating current to direct current. Amperage, the measurement of number of electrons moving through a conductor. The current is measured in amperes or milliamperage. Voltage is the measurement of electrical force that causes electrons to move from a negative pole to a positive one. Voltage is measured in volts or kilovolts. Electricity and electrical currents, milliamperage adjustment, can increase or decrease the number of electrons passing through the cathode filament, and kilovoltage peak adjustment can control the current passing from the cathode to the anode. A path of electrical current filament circuit uses 3 to 5 volts and regulates the flow of electrical current to the filament. The high voltage circuit uses 6,500 to 100,000 volts, provides high voltage required to generate the X-rays, and is controlled by the kilovoltage settings. A transformer is a device used to either increase or decrease the voltage in an electrical circuit. 3 transformers are used to adjust the electrical circuits: a step down, step up, and an auto transformer. The step-down transformer is used to decrease the voltage from the incoming 110 or 220 line voltage to the 3 to 5 volts used by the filament circuit. The step-up transformer is used to increase the incoming voltage used by the high voltage circuit. And the auto transformer is a voltage compensator and corrects the minor fluctuations in the current. Production of X radiation. The production of dental X-rays, types of X-rays produced, and definitions of X radiation. Production of dental X-rays. Electricity from the wall outlet supplies the power to generate X-rays. The current is directed to the filament circuit and step-down transformer in the tube head. The filament circuit uses 3 to 5 volts to heat the tungsten filament in the cathode. Thermionic emission occurs and the release of electrons. The electrons stay in an electron cloud until the high voltage circuit is activated. When the exposure button is pushed, the high voltage circuit is activated. The molybdenum cup in the cathode directs electrons to the tungsten target in the anode. When electrons strike the tungsten target, less than 1% of the energy is converted to X-rays. The remaining 99% is lost to heat. A small number of X-rays are able to exit the X-ray tube through the unleaded glass window portion of the tube. X-rays travel through the unleaded glass window, the tube head seal, and the aluminum disc. The size of X-ray beam is restricted by the lead collimator. The X-ray beam exits the tube head at the opening of the PID. Types of X-rays produced. X-rays differ in energy and wavelength. Two mechanisms: general breaking radiation and characteristic radiation. General radiation. Many electrons that interact with the tungsten atom undergo not one but many interactions within the target. Most X-rays, about 70%, are produced in this manner and are produced when electron hits the nucleus of a tungsten atom or passes very close to the nucleus of a tungsten atom. Characteristic radiation is produced when a high-speed electron dislodges an inner shell electron from a tungsten atom and causes ionization of that atom. The remaining orbiting electrons are rearranged to fill vacancy. This occurs at 70 keV and above. Definitions of X radiation. Primary radiation, the penetrating X-ray beam that is produced at the target of the anode. Secondary radiation, X radiation created when the primary beam interacts with matter. And scatter radiation, a form of secondary radiation that the result of an X-ray that has been deflected from its path by an interaction with matter. Interactions of X radiation could include no interaction, absorption of energy and photoelectric effect, constant scatter, and coherent scatter. No interaction, meaning the X-ray photon passes through the atom unchanged and leaves the atom unchanged. The X-ray photon is completely absorbed within matter or the tissues of the patient. Absorption, meaning the total transfer of energy from the photon to the atom of matter. And photoelectric effect, an X-ray photon collides with a tightly bound inner shell electron and gives up all its energy to eject the electron from the orbit. The ejected photoelectron is absorbed by other atoms. Compton scatter, the X-ray photon is deflected from its path during its passage through matter. In Compton scatter, ionization takes place. The X-ray photon loses energy and continues in a different direction, but at a lower level energy. The ejected electron is termed a Compton electron. And coherent scatter, an X-ray photon that has a path altered by matter. A low energy X-ray photon interacts with an outer shell electron. No change in the atom occurs. and an X-ray photon of scattered radiation is produced. This concludes our lecture.